All right, we're going live. It is the 16th of October, 2024. Hey, everybody. It's Plutus PBL live coding from Gimbalabs and Friends. We are finishing up a couple of videos to accompany the Plutus PBL course. And yes, Seb, what do you say?
Yeah, in some moment, could you show a little bit about the Aiken demo you are working on?
Yeah, definitely. Can we do this example and then jump into the Aiken examples we're working on?
Great, great, thanks.
Yeah. Um, so yeah, we have the videos for these previous three videos have been published, or sorry, these previous lessons. And there's one more to go here. Just trying to play with a little thought experiment to talk about what an indexer does. And so I wanted to try a silly kind of hands-on example to build up a reason why indexers exist, not to go so deep into covering all the ways to implement one, but just in case you've been hearing this word around the ecosystem and you're wondering, what indexers? Why do I need that? I'd like to try to answer that question here. All right. And so let's back up for just a moment and head over to the course examples. Oh, please. And this is going to get us up to speed on the prior examples from this module, right? I can connect a wallet. And when I do, I can see some information in the other examples. For example, I can see that I have minted a token, for example, and now I have access to this very simple application. That's all well and good. But often we need to get information from the rest of our blockchain and not only from our wallet. And so what you saw in the previous lessons is that we can query the blockchain with Blockfrost or with Maestro or by using built-in mesh providers that service Blockfrost, Maestro, and other services. And in any of these cases, we can hit an endpoint and get some data. Fine. And if you want to see the source code for this example, once again, go back to lesson 204.1. But here's the core problem that we might start looking at. If our goal was to have a list of tokens minted with some policy ID, of course, we can always make a query to somebody else's API, to the Blockfrost API or the Maestro API. And if we do that, that query is going to be run every time somebody looks at the web page, because the way we've implemented it so far, this is just running in the browser. It's making this query on demand, and it's pulling this data into the user's browser. But I hope you might start to wonder, isn't that inefficient, right? A Blockfrost or a Maestro call costs money. What if there was a way to not have to rely on hitting that service over and over again? Because the blockchain, once there's blocks on it, it's not going to change, right? This list of tokens that was minted between, say, March and September of this year, that's already on chain. And I don't have to worry about that current data changing. There might be new data in that data set, right? And so what if we could just keep some kind of list off chain and we only need to update it when a new token is minted? And if you understand that idea, right, keeping something separate from the blockchain that's updated when certain kinds of transactions happen, now you've got the basic idea of what indexers do. And if you don't have a full idea yet, I'd like to actually just be the indexer. I'm going to show you doing by hand the long way what the indexer sort of does. And that's going to allow us to think about how efficient it is to do it by hand. And once again, why an indexer is helpful. So let's look at just a little bit of the code here. There's an example for this component. Where is it? I think it's in the, whoops. Let's go 204.1. We've got some examples here. This was the token datum. Go back to that lesson. Where was that example? In query by policy ID. That's what we'll use. Query by policy ID was our example of a block frost query. Yeah, and there's a line commented down here. So obviously you can console log data anytime, and sometimes you can just JSON stringify it if you want to just see some raw data on the screen. So that's what we're going to do here. And I think, oh, I need to working on a different computer today. Give that just a second to update. And you'll see this on my screen in just a second, but the idea here is we can just look at the raw data of this query. We're going to be able to see it on the screen. Let's just get these updates. Mesh has been pushing all sorts of updates lately. This should be good now. Yeah, fine. Okay. And so I uncommented this string right here. And now I'm just going to run this server. And I'm going to open up this same page, but on local. Okay, we're loaded up. And now when I run this query, oh, do I not have, my fault. Give me 1 second here, guys. I'm sorry. I need my block frost key. Let's try that again. And what was just happening under the hood is I had to pull in the API key for block for us. I didn't have it locally here. Let's try that again, and we'll go back and look at that example. And I'll share screen again. Let's reload and try it now. There we go. Okay, so this right here, this is the result of just that raw JSON.stringify. And if I look at where this is coming from, this is the This is the data that's being returned by this API call right here. Okay, so we're querying assets policy, this policy ID, looking at the raw data. What is that raw data? It's just a list of assets with an asset ID and a quantity. And I think all these quantities ought to be one because these were minted one of, right? When everybody mints their token. Fine. And of course, that being the raw data, here's a slightly more user-friendly version that still is not production ready, but just to show you, right? You can look at the source code to see how we're making sense of the raw data by just mapping over it and then converting a substring to the name you see here. Okay? But this raw data is what's in question. And if we go back to the example, you can see that, of course, anytime I can copy and paste this. Or a little more advanced way to do it, if I logged this to the console or even saved it as a file, TypeScript provides ways to do that. But we're really doing it the long way by hand right now. All I'm going to do is copy and paste the data I see right here into a file. In this example, just a tokens.json file in a data directory. And there it is. Once I have this, I can do something like this instead of using a live query. So let's just make a live update to this query by policy ID file. Okay. What we can do is we can say, let's just comment out the query in the first place. Let's pull in, let's pull in this import tokens line right here. And then there's a lot of stuff we're not going to need anymore. Okay, we're not going to need to set data as a use state hook, so I'll comment that out. We're not going to need any of this use effect because we're not making this query anymore. And we no longer need to toggle the fetching of the data, right? Because it's already here. It's just in this JSON file. So that's actually going to be really efficient. And I'm going to comment this line out again for now, but, oh, it's called data, but let's just call this tokens instead, because that's what we're calling it in our import, tokens. Okay. We can get rid of the button. And we've got some unused imports, but that's not going to hurt anybody. But I will need to just have an opening div here. How's that look? Okay, so we've got a couple of unused things, but we're not even going to keep this code right here. I just want to show you this example. That ought to work. Let's just run that server again. And there's something really important that's going to happen. Which is that the data is already here as soon as I load the page. And of course it is, right? Because it's right there in that JSON file that we were just looking at, right? Now, obviously, I'm cheating right now. The truth is, if you're running an indexer, you're still going to have to host it and serve it from somewhere. But the idea here remains. Now I've got some data that's off chain, and this is kind of an extreme and contrived example, but you can see that my app is more responsive. And so if you're going to build an indexer, you Of course, you should make sure that you can deliver one that's going to be at least as reliable as a service like Blockfrost or Maestro. And if you don't have the DevOps skills or the access to servers to do that, of course, those remain useful tools. But a lot of this is getting easier and easier with patterns showing up. Okay, so this is the example. And just to review, right? Steps 1 to 3 are actually really helpful for other reasons. When you're prototyping some application UI, when you're trying to go from something ugly like this list that doesn't really help me to some UI where you might make some sense of this data in a way that's helpful to users, this is actually a really good strategy. Yeah, just grab some raw data, slap it in a JSON file, and then prototype, right? Just play around with UI, play around with the structure of your components and colors, whatever else you want to play around with. That's fine. But step 4, I hope you recognize, is just ridiculous. You're not going to update a file by hand every time something happens on chain. And so now we come back to the original question. An indexer is going to help you automate this step of updating your trove of data over and over again. You can set up indexers to track the blockchain and to update stored data according to certain rules. And then you can look beyond that step and think about, okay, well, now that I have this raw data, maybe it's just a list of policy IDs, maybe it's just a list of raw transactions. You can now manipulate that data in any number of ways to make it useful. And you can deliver that processed data via an API endpoint that is reliable as you're able to build it. We're not going to go deeper into building indexers right now, but we encourage you to explore. Here's one public resource from Builderfest that happened earlier this year. A group of developers got together just to make a little mind map of the different indexers that are out there. So if you've ever heard any of these words, we were just looking at Blockfrost and Maestro. And here's some high level descriptions of those from the way a dev might describe it. And then here's other options for building indexers or things that serve a similar role. And this is a really, really nice place to start. Just Google any of these terms or search for these in the Discord server of your choice. See what you can find. So is this helpful? How are people feeling? Is anybody here who has heard this word indexers, but has not really wrapped their mind around what it is? Or maybe have you seen any of these words on the screen right now and been wondering what makes them special? Questions or thoughts? Harsha, what do you think?
I have a small question. So when I'm running the node, I see like a folder that says Cardano DB sync with the node. Is it the same thing? Am I directly like indexing using SQL?
Beautiful. Okay, great question. Yeah, so when you install Cardano Node out of the box, it comes with several different programs, right? And the two that we talk about the most are Cardano Node and Cardano CLI. But as you noticed, there's some other things there too, and DB Sync is one of them. It doesn't work automatically out of the box. Okay, so if you've ever looked at the config files for setting up, and you were just doing this over the last few days, right? So you've got the config files locally. You're able to reference the ones you need when you start up the node. But there's some other config files that are included optionally. And I think actually, let's go take a look at that. Can I find that real quick instead of just talking about it? Yeah, let's just look at it in a file explorer to make this make sense, right? So I've got the most recent node right here, and it comes with this share folder, and there's a pre-prod directory. No, it's not included directly there. But the tools are there. DB. Okay, yeah, we got to go to the configs site. Here we go. So you see this guy right here, DB sync config. This is an additional config file. There's also the submit one, right? So these are the two things that if you're just running a local node to make sure you can do it, if you want to give yourself Cardano CLI functionality, you can safely ignore both of these. But these are going to help you kind of go to that next step of application building. And you need this config file to run DB sync. Now, that's only a tiny part of the story. DB sync takes an order of magnitude more time to sync from Genesis than just your node does. Because when you sync Cardano node, sure, you're getting the block history of the blockchain. But when you want DB sync to be fully up to date, that's basically giving you the table with basically all the available details of every transaction that's ever happened. And clearly that's a lot of data. So that's, and it's only becoming more data. So that takes time. And there's some nice solutions for not needing to do this from scratch. But this as well is a reason why indexers exist, because really recognizing for now at a high level, the thing you need to know is that running a full DB sync is very resource intensive. And if my goal is only to be able to see transactions that include a certain policy ID, and maybe that policy ID has only existed for the last 6 months, then of course I don't need to go all the way back in time and know the entire history of the blockchain, nor do I really want to use hard disk space to have all of the global transactions that are not relevant to my policy ID, right? But if I was running like a blockchain explorer, like Cardano Scan, or if you were operating Pool Tool, or under the hood of GraphQL, which a lot of you guys are familiar with, DB Sync is running, right? And in order to be able to make a global GraphQL query, this is going to be required. What else are you thinking? All right. So Seb, cue the outro music. That's the end of lesson 204.4. We'll call it there. I want to practice explaining that, and this is just a first draft of this idea. So let's keep playing around, and as you guys go a little deeper into app development and you do experiment with different indexers, be sure to be in touch with what questions you have. Remember, you can ask questions in the chat at the bottom of any lesson or bring them straight over to the Gimbalabs Discord. And there's a million different directions we can go with this. We're going to cover Adder specifically in the Go PBL course, which is in development right now. And there's already some resources over there that will introduce concepts around Adder if you want to get started. Yeah, basically, there's just a little overview of it right here. But we've got a few really nice examples that are going to show you how to run one kind of indexer from scratch. And you'll learn a lot more about where it's pulling its data from over here. But I think we can call it a wrap on module 204. There's an assignment here for anybody who's ready to keep going. This assignment has important stuff that everybody should try to do, neat stuff that you might want to explore, and a challenge assignment called Tough Stuff, where you're going to have to do some research on your own and figure a couple of things out. But of course, if you get stuck on the tough stuff, that's a great chance to ask questions, come to a future live coding session and we can look at this together. All right, so that brings us to validator essentials. And what's new this year is that we are introducing these concepts of validators by looking at Aiken examples first. We recognize that there's a lot of people who that's a much friendlier onboarding option. And so even though the concepts translate between Plutus TX and Aiken and other on-chain languages, we thought the best way to demonstrate these concepts would be in Aiken. So Hinson and I built a draft of the course for the live sessions in Hong Kong right before the official release of Aiken. And so we've been updating the examples one by one because there is some new syntax here. And actually, Matthias, it's so awesome that you're here today because I was actually marveling at the change to Cardano transaction from Aiken context. Was that an easy decision to make to go this route?
Nope. API, modules API and stuff like that. It's always a bit tricky, and it's never something you get right from the start. That's kind of why I'm also here today. Like you need to watch how people use the stuff and what's the common mistakes that people make and so on. And there are still things that that gonna evolve. For example, we are thinking about renaming policy ID completely to script hash because we see people keep struggling with the term of policy ID and how a policy ID is actually the same thing as your script hash when you write a spend and mint combined validator, right? So sometimes just in the naming, you see how difficult it can be or how it can create like artificial barriers. And so, yeah, it's never easy, but it requires just watching and observing how people use it. So that's not something you could get right from the start usually.
I love it. And it's good to hear that wasn't an easy decision. And yeah, so how, in your mind, do you still use the word context when you're talking about validators? Like I'm still trying to decide, like, do we introduce transaction in the first example, which is right here. And for now, I'm calling this one introduce transaction context, but it's only really because I can't let go of this word.
To be frank, I think I'm doing something a bit controversial nowadays, where I used to call now the transaction, I just call it self. It has this oriented object kind of vibe to it, but it really is what it is, right? We are validating the current transaction, right? So self is really this thing. So like you have self.input, self.outputs. And I think this reads kind of well in the flow of writing the validator. And to me, the context is everything, right? The context is the whole validator.
Right. This validator only applies in this transaction. So I might as well call it the transaction itself. Self.
Yeah, fundamentally, that's a bit the way I see it.
And then the context is the superset of that. It's like the validator and everything.
Yeah, I mean, context is really this whole like package you receive from the ledger, which contains the transaction, your datum, the redeemer, and your script purpose.
Mm-hmm.
And what we do now in Aiken is that we unwrap that context for you, right? And there is this new syntax where you get the components of that context readily served to you. But why this hasn't changed much compared to the previous, Aiken syntax? What people don't see is behind the scene, the way the context is being passed by the ledger to the smart contract has drastically changed. And this was introduced in CIP 69. This is what allows to have an optional datum now and no longer be blocked when you forget to put a datum to your output. So this change have completely altered the way the ledger passes in the context to the smart contract. But we've added some extra kind of logic in the compiler of Aiken that it will unwrap things for you, so that as a developer, you still have to just deal with the internals and the components of those contexts and not the raw context. You only have to deal with the raw context if you want to, and this is what the else branch is for now. The else branch is really like, okay, you don't do any unwrapping for me, don't assume anything. I'm going to handle the context because I know what I'm doing.
I didn't know that. And will that alpha branch last into the future?
Sorry, what?
Will the alpha branch last? Can we count on that being around just in case people want to screw around with it?
Oh yeah, I mean the versions, we're not gonna take that down. So
Right.
we still have a few people that are running on the 0.29-alpha version, which is the latest stable alpha. So no, that's one's gonna stay. I don't see any reason for any new joiner to not use the latest version. And to not rely on Plutus v3, if only for the various optimizations that are now part of Plutus v3. But if you have an existing project that you were kind of already working on that's not been deployed yet, well, you might stay in the previous version. That's completely fine. It's just that you won't get the new, compiler fixes and the new compiler features, because we won't backport anything to the previous versions.
This is really helpful. Thank you. So actually, yeah, in the datum, this is where I'm still fully, I haven't sufficiently updated my own mental picture of all this stuff to understand optional datum as a tool, you know? And so playing around here, moving forward, because of Plutus v3 and how datum is now handled, that's why this is really going to be kind of the bare bones way to use datum. Is that right?
Yeah. So the datum is always an optional thing.
Right.
It can be an option of anything you want, and if you really want to kind of discard it, you can always have an option of data. But the compiler will enforce that you put an option in there to make sure that you handle the case where it's there or when it's not.
So this, for everybody who's checking this out, datum can be an arbitrary data type. So it would be fine for me, and you'll see this in future examples, right? I could have some custom datum, and I could give that some fields, right? And maybe make it something like we've already seen, right? The number could be an integer, and info could be a byte string. Or is it just bytes? Let's look at my other examples.
Byte array.
A byte array, right? And so if I define a custom type like this, I could now go right here and I could make that the datum. But no matter what, whether it's a custom type like this or just a primitive type like an int, it now needs to be wrapped in option. And this has a few syntax implications right away. But this is the thing, I was just working on this earlier today to make sure the first part worked, and we were building up some transactions. And we can look at that in just a second. But if I leave, how do I capitalize on the fact that I still want, now I would now in the future want a UTXO without datum to be spendable? Because if I'm understanding it right, I still haven't made the UTXO that includes no datum spendable, because is valid will return false if there's no datum.
Exactly. So if you wanted to do that, instead of expect here, right, you would pattern match on the datum opt. You would do a when is, and you will handle both cases separately. So when it's there, you would do the current logic here. But when it's not, you might do some other logic. And maybe you authorize the spend if there is some specific signature or if other conditions are met. But it gives you the control of specifying what you want. And if you always want to expect the datum to be present, then you can resort to exactly that, right? Expect some
Yes.
datum. And so you fall back to the old behavior that way. But you always have the option to go with when is if you want to provide a different execution path.
So what's the syntax? So when datum is, I'm still learning my exact syntax here.
And I need some curly braces, because then
Right.
it takes a block with clauses, and you're gonna have two clauses, one which is some datum, and then in a row, and the other one which is gonna be none.
Right. And so this could just return true.
For example, yeah. And in the some datum, you would put the two lines that you have below.
Yeah.
You would nest them under that. Yeah.
Great. Okay. And so now, yeah, this is great lesson content, because we can, whether we call it the old way or the, requiring datum, we can show people this, but also okay, that's good. That's a really helpful pattern to recognize. And my syntax is not good enough to get formatting. I'm doing something wrong.
You're missing an arrow after the pattern, some datum.
Oh, yeah. This would...
No, after some datum.
Oh, yeah. Right.
That leads to the block, yes, indeed.
Yes. Thank you. Okay, when datum is sum of, oh wait, when datum opt is sum, in this case, it's going to be an int in this case. I'm just going to call that datum int for clarity. Okay. Is there type checking at this step?
The type checking happens before, right? It happens because in your signature of the function, you've indicated you want an option int.
I want an option
So
int.
if it's not if it's an option of anything else, the validator would be rejected altogether.
You really picked a nice day to drop by. Thank you. Really nice. Right. Okay. Datum opt, we want an option int. So when we get that, we say fine. But this validator will be a little buggy, because it won't just return true if there's no datum. This would also return true if the datum was something other than an int. It would just be like always succeeds.
No, that will fail.
That would fail because it would see some
It will not execute the body of the spend handler. If you give it anything other than an option int, it won't even execute the logic. It will fail at the validation of the arguments.
Great.
Right? The redeemer and the datum always gets validated against what you specify as a signature.
Great.
And it will also not execute the else branch, which is one of the confusion we've seen in some people, right? You only get to inside the else branch if you don't match the specific handler. Right. So if you try to mint, for example. But here, since you have a spend, it's always going to go to spend, and then you've fully specified the contract of your spend handler. And the contract say it has to be an option int. If it's anything else, the contract is broken, and therefore it fails.
Yes. Perfect. And just to make sure everybody else gets that point, right? Look at just this entire block right here. We've got that didn't really help. but we have a validator called introduce datum because we're teaching about datum for the first time. And right here we say, okay, we've used the word purpose in the past, but maybe we're updating some of that language right now. But the purpose of this validator is spending. And if you try to use this validator for any other purpose other than spend, and Matthias gave the example of Mint, but right, you know there's some other ones as well, then this validator fails. I will not be able to mint tokens with this validator. I will not be able to sign for rewards with this validator. Certainly won't be able to do governance actions. But then once we're inside of that spending, I still want to use the word context there. Once we're inside the spending context, now we look at the transaction. Transaction has a whole bunch of fields in it, and we're going to behold the entire transaction over the next few weeks. We're just looking at the validity range. And then we use a helper function that's pulled directly from the Aiken docs. Really hope people will follow through and just look at the official examples as well. We say, okay, let's use that function, but let's just use a version that says you must start after some deadline. Okay. And so now we're ready to just compare these two possibilities. Right? Backing up, before we go a little deeper into that datum example, here's an example that doesn't yet use datum. And the reason I know just by looking at this code that datum is not going to be required is we have an underscore right here. And that's just a helpful little tool built into Aiken that says, yeah. You can define datum redeemer and input, but we're going to ignore those when we get to the actual logic right here. The spend versus other purpose pattern is the same. But in this example, all we're doing is we're checking that the transaction happens after some lock time.
So if
Here's
I
why
may
this,
on that
okay.
one, there is still some validations that will happen on the datum, right? It's only used in the what we call the handler of the purpose here, because it's been discarded, right? But you still specify that its type should be option int.
Right.
And that
right.
means that Aiken is still going to check that the datum abides by this type. So if you really wanted to completely discard it, you would put an option data in there, because data is basically anything, right? Anything can be data at the datum redeemer level, which means any possible representation of the datum is now mapped by that. If it's not there, that's going to be the none case. And if it's there, then that's necessarily going to be invalid data, because the ledger enforces that.
Yes.
And now you have fully discarded anything about datum, and it could be anything.
Okay, let me ask you a question about that. So the reason I left it int here is actually because of the redeemer handling. And I was struggling to figure out how to explain that although open-ended, even this requires people to put some structured a structured data object together. And it felt too hard to show people like that data can really be anything. And that's why I wanted to ground it in int right here. But that kind of leaves it doesn't tell the whole story, like you just said. So I'm trying to.
You can also leave no annotation, right? If you leave no annotation at all, the compiler would just assume data. So the most general case possible. So if you just say, here is an empty redeemer, right? You still need to have the arguments being there, being discarded.
Right.
But you wouldn't put anything after the colon. You just say, there is some redeemer. And I don't even specify the annotation because...
What do I do?
Nothing. You just remove the colon.
Oh, right.
Yeah. So you still need the comma at the end to say, well, there is some datum, there is some redeemer, but we don't annotate their type.
We don't care what. And so in this case, I could use a naked value or any kind of structured data.
Yeah, since you don't specify anything, the compiler is going to assume the most general thing possible it can assume at this point, because we have type inference within Aiken, which means the compiler tries to figure out the types from how you use them. And since here you don't use them, then necessarily they have to be the most generic thing they can be, which is option data for datum and data for the redeemer.
That's good. So this is like our most general example, because what we're having people go now and actually build and then even deploy as a reference script these. But the reason we're doing that is just to frustrate them enough that they really want to learn about testing. So, and then the testing, that's how the Aiken PBL course is being built right now, is we don't even touch on-chain interactions. It's all testing. So people see this for the first time, they'll get these validator concepts, they'll go have to bang their heads against some transaction building for a little while. And then once they get in the habit of that, then we can say, okay, if you feel good about how transactions are working, now jump over to Aiken PBL, where we're not going to make you do that part again, and we'll show you how to run tests. But this is nice. So this gives us a general example where we're not going to beat people up right away. This is just the first transaction example. Then we can show people, hey, actually, let's introduce datum and redeemer. And this just introduces an example where, in addition to being passed some time, the datum and redeemer just have to match.
Yeah. And if you want, you could even go one layer more general, if that's a path you want to explore. But it would be to completely omit the spend validator altogether and just work from the else context. Right? So else you get a single argument, which is this script context. So now you're back to a single script context. But inside that script context, you've got three things. You've got the datum. You got the redeemer, you got the transaction info, and you got the purpose. And at this, if you don't even want to mention that, you don't even have to talk about the purpose at this point, and just talk about the transaction inside it and do the validation of the transaction. And that means they will apply to every purpose.
That's really interesting. Okay, so if I'm understanding right, we'll have something like this, no purpose. We can put all of this inside the else.
Yeah, and you will receive a single argument here that you can call the context, right?
Yeah.
And then the TX that you have here, you can just replace that with context.transaction.
Right.
If I remember correctly, actually. I don't use the script context often.
Yeah. And context, where would that type be imported from now? There's still a context that I can import.
Yeah, it's under Cardano/script context.
Great. Let's go.
And it's called script context as a type.
Cardano script context, yeah. And this has just script context there.
And you see it has three things. It has the transaction, the redeemer, and the script info, which is very much like the script purpose, except there's a one tiny difference, which is that the spend purpose will also contain a datum in here, an optional datum.
Yes, which is flexible, right? There's some flexibility that comes with that. I would love to
using the script context manually means that, you're doing things manually, right? So you don't want the Aiken compiler to be pulling these things out of the script context for you.
Yes.
And it could be, as an introduction, a good way to kind of brings down the complexity. So initially you can completely ignore the redeemer and script info part, and just say, well, there is a transaction in the context. Here is the validator. But actually that means this, this particular code here will validate spending, minting, voting, everything. Now,
yes,
if you want to restrict them,
right.
right?
Which is
You can,
beautiful. I love that. Okay, so yeah. This is really cool. So if we start here, all right, here's a really basic, we're going to ignore a whole bunch of stuff, but we're just going to show you, look, here's a validator. And we won't even explain this the first time through. Here's a validator that works after some hard-coded deadline. By the way, it can do anything. It could spend, mint, et cetera, et cetera. So let's go one step further. Let's limit this validator to just spending. We could also make,
I see someone asking in the chat if it's a best practice to use else. And it's not really that it's a best or bad practice, right? It really depends on what you want to do. The reason we introduced that in the language, because we could have done without, right? And just said, you provide a set of purpose, and the one you don't provide, we automatically fail for them. But we kind of don't like doing implicit behavior that people are not aware of. So having an else branch forces you to specify what's this else behavior. And most people will just do else fail. But at least it's clear, it's written down, else you fail. If you want to do else true, you can. So that was the first reason we wanted that. And the second reason was kind of thinking layer twos. And here that's going to be a bit far, but this whole syntax is thought of. This works for Cardano because for Cardano you have those specific spans, purpose, and so on. But you could imagine a layer 2 that's also making use of the Plutus VM, and that would have different actions because maybe they have programmable tokens there and they want to have new purpose, like, I don't know, accept, where you can have contingency transaction. And so you would have different purpose that your layer 2 would define, and they would immediately translate into these new, Aiken handlers. But while we get there, we still want to have this escape hatch of, well, here's an else where you get a script context that can be whatever is, whatever works for your particular environment context. And in Cardano, it's specified by the ledger. On the layer 2, that might be something slightly different. But now at least you have a mechanism to implement validators on different layers with the kind of same unified syntax in a single file, and they would all share the same hash across different chain layers. And that simplifies a bit the passing, between bridges and so on, because now you have a single validator that can work cross-chain on 2 layers, like on L1 and any of the L2. So that was kind of an anticipation of that. And for now, the else branch gives us an escape hash for that, until we worked out how to properly define the script context and the purpose based on your execution environment. So yeah, it's really just a more mechanical way of accessing the script context. And I would say in most usage of Cardano, you don't need the else, and it's just more convenient to use directly one of the purpose. It's also more transparent about your intent. Because you will see that if you just use the else, rapidly what you're going to do is you're going to start to do a when is on the purpose inside it, and pattern match depending on, okay, if it's a script, if it's a spend script, I'm going to do this logic. If it is min script, I'm going to do this logic, and so on, which in the end is exactly what you get with this purpose syntax that we've added to the validator. And the else forces you to think about, well, those other purposes you don't explicitly handle, what do you want to do with them?
hey, Caesar, by the way. Hey, Lucas.
Hey, well, good morning on my end,
Yeah, good morning here.
Everyone.
Good afternoon, Europe.
I didn't realize my mic was open. Sorry.
It's good to hear you, man.
Cheers. Same.
Very cool. Okay, so just for fun, if anybody's looking for something to play with here, and I want to add this as an assignment, certainly in the Aiken course, but this might be a fun, like, neat stuff. Let's go throw this over here. We're just drafting an assignment anyway. Let's go. Just jot a few ideas. down in the assignment at the end of this intro module. Because there's something interesting we could do. I'm not sure if this is neat or important or tough. Build a validator that mints until some deadline, and then allows claiming after. And this would be that mints to specified address. This could be a really fun project for anybody who wants to start exploring it, and we can think about what Rails to build. But if you're just wrapping your mind around validators right now, and especially looking at new Aiken patterns, right? We now have the ability to say, hey, look, spending is unlocked after some specified time. But right in this very same validator, you could have minting that was possible until, right? Let minting allowed until, right? And it might be the same value. This could turn into a parameter, and we'll get to those in 3 lessons from now. But this would be a really fun exercise. Try to build a validator that has both minting and spending endpoints. It allows minting until a deadline and unlocking after that deadline. But the gotcha here would be to figure out how to make sure that minting is only allowed to happen to some address. In fact, to this address. Okay. So that'll be kind of a fun exploration. And if anybody wants to run with that, give it a try. And we can scaffold for that project as we build out the rest of these lessons. But that could be a really fun exercise. Any questions about that? Sorry, I'm getting a little ahead of myself, but that would be really fun. Before we keep going, any other questions based on what we've just been looking at?
The only question, but I think there's a video about it, so I'm hesitant to ask it, is the way in like the validity range and how it's like, so I tried watching the video the first time, not in Gimbalabs, but the one provided by the Plutus, or the Pioneer program. And I still had to, like, I think I need to go back and rewatch it.
Man, it'll break your brain. So yeah, let's actually spend a few minutes on that. All right. This number right here is expressed in what's called POSIX time. These are the milliseconds since January 1st, 1970. I don't exactly know why it's called POSIX, but what you need to know is that if I made it just seconds, this is called epoch time or Unix time, okay? And for me, what the word POSIX just means is that it's Unix time, but in milliseconds. And this is what we're actually using inside of validator code, whether you're writing in Aiken or in Plutus TX. The problem with this is that if I look at a node, and I've got a synced preprod node right here, the node is reporting time in slot time. These are the seconds since this blockchain was turned on. And for now, it's sufficient to understand under the hood, this slot time can be translated to a POSIX time, but they're not the same. And it would be easier to write this. Well, I don't know, right? I don't, as an app developer, I actually don't care what blockchain time is, right? So that's kind of why this is so convenient. Yeah. And because different blockchains have different start times, right? We have to use absolute time in our validator code because otherwise that would have to be a different value when I move between networks. Are there other reasons for that?
What if you're just looking for like the time of the next epoch or something like that?
Yeah, you want to build a validator that changes behavior at an epoch boundary.
The thing is, you're talking about multiple networks,
right?
But you also have the problem with the existing network, right? There is no guarantee that the slot remains what they are,
right,
in the next hard fork, right? We can always change the slot time, and this has happened once in the history of Cardano already, right? We used to have slot time of 20 seconds, now they are 1 second, and for that reason, right, your contract is better relying on something that might arguably not change, which is the definition of a second, than the slots where you only have visibility up to 36 hours in the future, actually. And that's also an interesting gotcha that people bump into usually, is at some point in time, you might try to construct a Plutus transaction or a transaction that contains a Plutus script, which has a validity upper bound, which is more than 36 hours in the future. And that is going to fail. The ledger is going to reject your transaction and going to tell you that it is past the foreseeable horizon. And what it means by that is that it has no guarantee from a consensus standpoint that the definition it has of the slot length and the epoch size and so on will not change in a 36 hours time window. Or after that 36 hours time window. It has only this guarantee doesn't change for the next 36 hours. But after that, hard fork can happen.
So, right, there's an absolute range in play. We have good reason. Yeah, I was trying to find reasons to doubt this, but as soon as I did, this is the only way to do it. You have to have seconds.
You have to have something which has a definition that doesn't change over a long period of time.
Right. Yeah, if the definition of a second changes, something else is wrong. So we'll leave that one.
I think the better question is why do we specify the validity interval in slots in the transaction? That's a much more debatable thing, I think.
Because just like we're able to calculate between this time and slots, we might as well be able to specify seconds in a transaction.
Yeah, but we are not always able to. That's also the thing, right? Because of this 36 hours issue.
Right.
So yeah, I guess we went for slots in the initial design of the Cardano blockchain just because it was more natural and felt easy, and it was introduced before smart contracts. And then with smart contracts, we kind of realized, oh, but we actually need seconds in the proper definition of time, and transactions were already in slots. And so that stayed. And now you have this weird discrepancy between the two. But ideally, I think you would just specify transaction boundaries in seconds, and the ledger would do that conversion because it has a clock. And anyway, it needs to maintain consensus.
Now, is the granularity of the slots based on the time interval between transactions or between blocks, or
no?
How many slots are between blocks, or because what's the granularity based on that versus the granularity of time when you're talking about
at this
POSIX?
point in time, you have one slot every second, and you have 5% of active blocks, which means that on average, you have one block every 20 seconds, on average. You don't really know when you have blocks. That's part of the security design of the consensus protocol behind. But yeah, at the moment, they map to one another.
Okay.
And so Caesar, I just shared my reason why I struggle with time, right? We got on the one hand, one measure in transaction building and another inside the validator code. What else? What are some other tripping points we should be aware of when trying to help people understand time?
No, that was it. I mean, for me, I'm glad I'm not the only one that finds that confusing. Because I was expecting the interval time to be the same thing that we use as far as like POSIX time, as you were saying. I thought they were going to be the same. It would have made more sense to me if they were like the same integer, or like, I could put
Oh
that
yeah,
in.
that number's the same as that number. Easy.
Yeah, and I could figure out the date, like, okay, this is where it's going to go through, but that isn't the case. So, okay. I just wanted to know that there is a difference, and I guess underneath the hood it gets converted or something.
Yeah, and it can go pretty deep on the rabbit hole if you start wondering about time, because now you might also think, you have a slot every second. When do you actually start measuring the beginning of a slot, or like that the slot happen? Do you take like the beginning of the slot, the end of the slot, the middle of the slot? What do you consider being in that slot from a ledger standpoint? I think the current implementation, if I recall correctly, on the Haskell node, consider the middle of the slot to be like the time reference for that particular slot. And then the clocks are synchronized by the microseconds. So you've got like this precision around that. But that's like, you can go super deep with time, and it's always super confusing. And at the end, it's just a bunch of arbitrary choices that some people made, and you just have to compose with that.
Yeah, I can't tell if you're talking about development or if this is just like an existential reflection at this point.
Probably both.
Can I ever possibly live in the moment anymore? And Caesar, the other thing I'll report is I still have to kind of like write it down on paper, because you got invalid before and then you've got invalid hereafter, and that defines the validity range of the transaction itself. But then I'd have to draw pictures. We should probably include some pictures in the lessons, because you have to think about the validity range of the transaction and then the validator's relationship to that, right? And sometimes I can't hold that all in my head without writing something down.
Yeah, and you mentioned pitfalls to be careful about, and the semantic of this interval has actually changed in Conway. This is an accident. It shouldn't have happened. And it was partly due to the rewrite of the specs in Agda and so on. But before Conway, the interval you specify in the transaction would be an inclusive interval. Now it's exclusive.
Oh, I didn't know that. Okay.
Yeah,
Missed
not
that
a lot of
detail.
people know that.
Yeah.
But yeah, the semantic has slightly changed around the boundaries, which means that if you were like really trying to expect things by the slot, well, now you need to always account for one more, because the bound is not exclusive.
Oh, somebody out there has been beating their heads against that problem and wondering why. Okay. But yeah, so we've got these. Okay, and that's changed from inclusive to exclusive, you said.
Yeah.
Yeah. Okay. Well, I think we've got some fun stuff to build upon. So the narrative, right? The other examples are still in development. We'll have these done by early next week. And then this full module 205 will be finally published. we might have we can share a link to this video in one of those lessons, but we'll do some focused dives into the next few. And so just to take a look at where we go next, right? We've talked a little bit about transactions, and we're going to change the learning target. So it'll be more about transactions than context. We took a look at datum, and just to think about the story, the context example shows us that it's possible to hard code a value. And these are just loose notes. It's easier to talk about this from here, right? We can hard code a time into a contract. That's all well and good, but really, it's not often practical. And it's more likely that you're going to want to be able to have flexible times that change where the logic stays the same. And datum gives us one way to do that. Instead of hard coding the value here, we put the value as an integer in any UTXO that's locked at this validator. A side benefit of that is that in this example, every time I change this number, it's actually going to generate a brand new contract address. Whereas if I use datum to make that number flexible, now I'm going to have a single validator address that can accept different UTXOs, each with a different unlocking time. And this one is a little bit closer to what the Aiken example shows. But that's still just transactions and datum. What's a problem in a narrative sense that gets us thinking about why we might need redeemers? And what we're going to do here is we're going to think, okay, well, yeah, sure. Nope, that's not it. Here, right? Okay, for the example we're going to provide is we're going to create the same validator, but we're going to make it possible for some owner or administrator to reclaim the tokens if they don't get claimed inside of some window. And so this example is going to show us how to use upper and lower boundaries, as well as two different redeemers. And then finally, we're going to wrap it all up in parameters. And we're going to say, okay, well, now there's certain values that we can bake into the code. And some of you have already seen parameters in earlier examples, but we're just going to make sure that starting from these two, it's kind of a very clear narrative that goes from one to the next. So anybody who's learning this stuff for the first time, I'll be really excited to hear if the narrative makes sense or if you have ideas for how to improve it for the future. Before we wrap, any other thoughts or questions? Cool. Well, thanks as always for hanging out. Matthias, really awesome to have you here. That was really nice timing, and I had a few of my own questions answered, so I really appreciate it.
Yeah, I've been wanting to drop by for a while actually, but never got the time. And since I'm on vacation at the end of the week, let's say my end of the week is getting a bit calm.
Good.
So
well, come vacation with us anytime. And yeah, I'll be really excited to get your feedback as we really do start publishing those dedicated Aiken modules.
yeah, looking forward to it, especially if you start building on the Go side with Adder and so on. I would be quite interested to see what's the landscape there.
Beautiful. Good. Exciting times ahead. Everyone, thanks. Caesar, I'll be sharing some details about PPBL maintainers probably early next week. We set up that initial channel, but there's just Catalyst and too much stuff going on this week to do it right. But for anybody else who's interested, we have a Catalyst proposal in, and the goal is to take the next step from PPBL, which has been published in 5 editions over the last few years, turning that course into a commons resource. And what that means is just owned and administered by anybody who jumps in. And we're going to demonstrate that there's a pattern of going from being a student to being a maintainer of the course to being somebody who makes decisions about when it's time to update the course or how to add to it. And all of that's going to be integrated with the contribution smart contracts that Andamio is building. But I'm really excited to go through this experiment because I think it has both technical and educational and social layers to it. And we get to hack on all of those at the same time. So if anybody else is interested, we already have 3 out of 5 maintainers who have volunteered, but we're looking for 2 more. And I think it's going to be a pretty exciting opportunity. Hit me up if you have questions about that. Until next time, have a good Wednesday, everybody. Thanks.
All right, bye everyone.
Cheers.